So we have a limits review and something new today that will help you and you'll love a lot. All right, first we're going to look at what the function at 1 is, and here's the function f of x. The function at 1, as we can see, is defined right here, which is the y value of 1. However, now we want to look at limits from the right and from the left, right-hand limits and left-hand limits. The right-hand limit literally comes like your right hand from the right, which is this way. And so you can see the limit comes from the right, approaches the y value of 2, and the limit as it comes from the left, which here's the negative, so from your left hand, is also 2. Since the limit approaching the right and the limit approaching the left converge at the same spot, then the limit does exist and it's 2. So this function does have a limit at x equals 1, however it is not continuous, and that is fine. And that limit is 2. Next, we'll just review some limit properties. So please pause this and write down the limit properties. And then we're going to look at some special trig limits. So here are the limit properties. And then the special trig limits, we looked at those last year, and we're going to look at those using a graph. So as you can see, here's the graph of sine x over x. And as x approaches 0 from the left and from the right, the limit is 1. And for cosine, here's the graph of 1 minus cosine x over x, and that limit approaches 0. So these are the ones we looked at last year. You can also see if we look at x as approaches positive or negative infinity, then that graph of both of those is getting closer and closer to 0. Next, we are going to learn something new that you're going to love, and it's called Lhopitals Rule. Again, that's L'Hopital. And we use this when we have an answer that's indeterminate. For example, if we plug 2 in here with direct substitution, we're going to get 0 over 0. That means you need to do more work. Usually the work we do is factoring or multiply by the conjugate or a giant 1. And this one, here's our new factoring, the difference of cubes. And so it looks like that. Then you can cancel out a 2, and you get x squared plus 2x plus 4, which when you plug in the 2 gives you an answer of 12. But there's an easier way. And the easier way is Lhopitals Rule. If you get an indeterminate form when taking a limit, that is, if the limit of f of x over g of x is 0 over 0 or infinity over infinity, then all you have to do is take the derivative of the numerator and denominator, and that is going to give you the same answer as the original limit. The most important part is that you must write this statement before doing Lhopitals Rule so you can show me that's what you're doing. So you have to write the statement in order to validate that you can use Lhopitals Rule. So once you write that, you're all good. And here we go. So we're going to write this limit since the numerator equals 0 and the denominator equals 0. Again, this is very important. Must write that statement. Then you can do the math. So that means this equals the limit as x approaches 2. We are going to take the first derivative of the numerator and the denominator. So according to the power rule, x cubed becomes 3x squared. And the minus 8, that's a constant, so it goes to 0. And the numerator, the derivative of x is just 1. And if you forgot that, it's x to the 1. So that's 1x to the 1 minus 1, which equals 1x to the 0. And anything to the 0 power is just 1, which is why it leaves us with 1. So once we've taken that, now we can apply the limit. So we can plug that 2 in, and we have 3 times 2 squared, which equals 3 times 4, which equals 12. So yes, I know it's a pain to have to write this, but it saves you a lot of time getting this. All right, have a great day.